Hello dear viewers, welcome to TV Math Hub. In our today's session, we shall be looking at question number 3 of our Wakisha joint mock examination that has been recently done by the Senior 6 Mathematics students. Question number 3 says, suppose the line B is perpendicular to the plane, which plane is given, and passes through the point C, which C is also given. Find the Cartesian equation of the line B. So that is what we are interested in getting. We are interested in getting the Cartesian equation of the line B. So from the given information, we can come up with the representation of what we are given. One, we are told that we are having a plane. So suppose this one is our plane. As we all know, the plane is having the normal vector. So suppose this is our normal vector n, which is normal to this plane here. So this n can be obtained from the equation of the plane. The equation of the plane is given as this. And to obtain the normal to the plane, you look at the coefficients of x, y, and z. So the coefficients for x, y, and z will give you what we call the normal. So for that case, the normal can easily be obtained as 3, -1, and 1. So if this is our normal, then we are also told that we have line B, which line B is perpendicular to this plane. So let us now try to put the line B. So we already know that this one here is perpendicular to this plane. So it means if B is also perpendicular to the plane, then we can also have this as B. Where we have the normal is actually also where we can allocate our line. So this line here is also perpendicular to the plane. So initially we had the normal. And again, we are saying this can also represent a line B. This can also represent the line B. But you know, every line has got what we call the direction vector D. So when you say that this one here is the line B, which line B is perpendicular to the plane, and you are also given that this is the normal vector, we also have across this one here, we represented the normal vector, also which vector is perpendicular to the what? Perpendicular to the plane. So you realize that D and N are actually the same, because this line here, the moment the line is perpendicular, if the line is perpendicular to the plane, then it means the direction vector and the normal vector are actually the same. So we come to a conclusion which says that if the line is perpendicular to the plane, then it implies that its direction vector D is actually equal to the normal vector N. So we are saying that this D and this N are actually equal. So that is the conclusion we shall make if the line is perpendicular to the plane. If the line is perpendicular to the plane, don't forget the direction vector of the line and the normal vector to the plane are actually equal. So for that case, we already know N, and for that we shall also get D. And D will also be same as 3, -1, and 1. So this is your D. But we know the general equation of the line. The general equation of the line is given as R, which is equal to A plus lambda D, where this D here represents what we call the direction vector, and this A is a point where the line passes. So that is the point on the line. And for our given question, we are already told that line B is actually passing through this point. So it means your A is actually same as 1, 1, 0. So this is actually your A. So this A here is a point on the line. So that is where the line is passing through. So for that case, as we all know, that R here is representing the general point on the line. So it means if we try to put that, the general point as X, Y, and Z, then we shall have our A. A is a point on the line, which point on the line is 1, 1, 0. Then plus lambda D. D is what we call 3 negative 1 and 1. As we said, this b and n are actually the same. So this is what we shall have. Then from this given expression, we shall need to obtain what we call the Cartesian equation of the line. So to obtain the Cartesian equation of the line, you will simply need to express x, y, and z in terms of lambda. So we shall have lambda in terms of x, lambda in terms of y, lambda in terms of z, and that will be able to give us the Cartesian equation of the line B. So let us try to do that. From this, we can easily say x is actually same as 1 plus 3 lambda. And what does this one mean? This means that your lambda is same as x minus 1 divided by 3. That is what we shall have. And also, we can have y, which is equal to 1 minus lambda. Make lambda the subject, so you will have your lambda as y. So we bring this one this side, then we divide. So that will be y minus 1 divided by negative 1. So that is what we shall have. Also, we shall have the last one, z, which is equal to 0 plus lambda, and that will be lambda. So you have lambda as z, you have lambda as this, you have lambda as that. So from these three expressions, you will obtain the Cartesian equation as lambda, which is equal to x minus 1 over 3, which is equal to y minus 1 over negative 1, which is equal to z divided by 1. So you can have that. So it means the Cartesian equation of line B, therefore the Cartesian equation of line B is this. So this is x minus 1 over 3, which is equal to y minus 1 over negative 1, which is equal to z. And this will be your answer. Yeah.